Hello and welcome. In this video, we're going to explore two fundamental types of transistors, NPN and PNP. These are bipolar junction transistors or BJTs, which are essential components in modern electronics. We'll discuss how they work, how they're different, and how they are used in circuits. Let's start with the NPN transistor. As you can see, it consists of three layers: the emitter, the base, and the collector. The NPN transistor is a type N semiconductor, meaning it has an excess of electrons, which are negative charge carriers. Now here's how it works. The base is the control terminal of the transistor. A small current flowing into the base, we will call this IB or base current, allows a much larger current to flow from the emitter to the collector. This is the IC or collector current. To be specific, when the base emitter junction is forward biased, meaning the base is more positive relative to the emitter, electrons from the emitter move into the base. These electrons then get pushed into the collector due to the reverse bias at the collector base junction. This creates a current flow from emitter to collector. In practical terms, when you apply a small base current, the NPN transistor acts like a switch, allowing a large current to flow from the emitter to the collector. This is why NPN transistors are commonly used in switching and amplification applications. Now let's look at the PNP transistor. As you can see, it's similar to the NPN, but with a key difference. In a PNP transistor, the semiconductor layers are arranged in reverse order, with the p-type material being in the middle and the n-type materials forming the emitter and collector. In the case of the PNP transistor, holes, which are the absence of electrons and act like positive charge carriers, move from the emitter to the base. When the base is made more negative than the emitter, this allows current to flow from the collector to the emitter. This is the opposite direction compared to the NPN transistor. Just like the NPN transistor, a small base current is required to control a larger current between the collector and emitter. In PNP transistors, this happens when the base is pulled low relative to the emitter. This characteristic makes the PNP transistor function as a switch as well. So the key differences between NPN and PNP transistors come down to current direction and charge carriers. In an NPN transistor, current flows from the emitter to the collector when a small current enters the base, and the electrons are the main charge carriers. In contrast, in a PNP transistor, current flows from the collector to the emitter when the base is made negative, and holes, that are positive charge carriers, are involved. Both NPN and PNP transistors can be used to amplify signals. For instance, in an amplifier circuit, small changes in the input signal at the base result in much larger changes in the output current, allowing you to amplify weak signals like audio signals in microphones or radios. In addition to amplifying signals, these transistors are also used in digital circuits where they act as logic gates. For example, an AND gate can be created using both NPN and PNP transistors to control the flow of electrical signals based on logic conditions. To summarize, the NPN transistor allows current to flow from the emitter to the collector when a small current enters the base, while the PNP transistor allows current to flow from the collector to the emitter when the base is more negative than the emitter. Both types of transistors are essential in electronics for switching, amplification, and logic control. So I hope this clears up the basic operations of NPN and PNP transistors. Thank you for watching.